there. Thanks for the question. So this problem involves vector addition, which I think might be confusing you in this problem. And so all that is we're going to write our forces in 2 dimensions in terms of their I and j components. And I and j just refer to the specific directions. So you could think of, I and j as just the same thing as x and y. And so when we write F1 as 10 newtons in the I direction and minus 3 newtons in the j direction, all we're saying is that the force number 1 is directed down 3 newtons and to the right 10 newtons. And so I've drawn out both forces here on the diagram to kind of help visualize what's going on. And similarly, F2 is 3 newtons to the right and 6 newtons down. And all you do when you add if you want to know the total force acting on the object, is just add the components of each of these forces together. So add up the I components with each other and add up the j components with each other. And that is your final result. So the total force is just 13 newtons to the right and 9 newtons down. And that's it. And what this problem's asking you is to write the acceleration, velocity, and position in terms of the I and j components. So you don't have to worry about having to calculate like a hypotenuse or anything. You just need to do the same one-dimensional acceleration, velocity, and position calculations as you've done before, but this time just on each of the different components that you have. So just to review a little bit briefly, right? Force is mass times acceleration. And so in this case, your acceleration in component form would just be your force, right? In the I direction divided by the mass. We'd stick the I on there to denote the direction. And then plus the force in the total force in the j direction divided by the mass. And then also indicate that that's in the j direction. Don't add up these two answers, right? Because then you're not writing it in vector format. You have to keep the components separately. You can't, it's not correct to add them together. And then similarly, you could say that the velocity of the object is just its acceleration times the time. And again, you would incorporate the vector components and keep them separate. This vector, invoke this vector notation, keeping the two components separate, but doing all of the math operations as you would normally do, right? And lastly, right, your position would just be 1/2 times the acceleration times the time squared. And again, as before, just remember that the acceleration is in this vector format rather than just a simple number in the one-dimensional case. So I hope this helps. Let me know if you have any more questions, and good luck.